And hello, welcome back to this video. I'm going to continue where I left off, and we're going to talk about switches and move on to Ethernet. Okay, so I just want to credit again this video geeks lesson for teaching me lots of the fundamentals. I'm just squishing it down to something a little bit more palatable, because that one has a bit of data overload for me. So I just want to switch it down to make it more understandable and palatable. Okay, and explain it slowly. I have a different style of explanation, of course. And of course, when I forget all this knowledge, I can come back and watch my own video. Yeah. Okay, so again, disclaimer, I am not expert at this. I'm just learning this, and as I learn, I'm making videos. It helps me with my memory retention, helps me to understand concepts, and hopefully it'll be helpful to lessen the confusion you're facing if you're in the same shoes as me. Alright, so where were we the last time? We were talking about computers talking to each other, and we were talking at how switches are this hypothetical device. Well, it's a real device that allows computers to talk to each other without jamming the whole information highway, like it does for a hub. So what I like to think of is this switch. Yeah, this device called a switch has some sort of a traffic control capability. So let me just delete all of this, and yeah, I'll just delete all of this, and let's start from a blank piece of paper, and then we'll have this picture of okay. Let me use black background and cyan. Okay, so we'll have this little switch here, and it's connected to 4 computers. Okay, there's one computer here, 2, 3, and 4. Yeah, I'm just slanting it a little bit to give it, make it a little less boring, depending what posture people have. So all of this will be connected to a switch. Now, I said before that what the switch enables us to do is for computer A will be able to talk to computer B. Computer A will be able to talk to computer B without interfering the signals between computer C and D. So this switch acts as some sort of traffic control, right? We call this traffic control. So it's a traffic control, and another way to think of it is it's like your local post office. This is a local post office. Okay, it's a local post office which, as A is sending mail, like letters, and is intended for B. This post office, so to speak, which is the switch, will be able to sort out the mail. And how is the mail sorted? All right. So let me have a new frame. Okay, how's the mail sorted? All right. So if you have ever written snail mail before, you know that there are a few things you need to fill in. You need to fill in return address. Okay, this is where do I return? Where is the mail from? Right? Where is the mail from? Okay, return address. Where is the mail from? So you write it somewhere here, and in another place you're supposed to write the to address, address of recipient. So where do I send the mail? Okay, so why is this called return address? I mean, in real life, your mail may get lost. So if your mail gets lost, then the place you actually send it to is back to where the mail originated from. Okay, I think this is how you write your mail. I can't remember exactly, But the important thing is that it must have a return address and the address of the recipient. So imagine when you send a mail packet, a packet of mail. Well, inside the mail will be your contents, your letter and content, and outside in the envelope you will have all of these information such as the return address and the recipient's address. So it is your address and the address where you want to send the mail to. So you probably just squiggle a few lines over here legibly, and over here legibly to tell the postman where you are sending the mail to. Alright. So for Ethernet it's pretty much the same thing. Okay, for Ethernet switches, it is pretty much the same thing. A will have to send a piece of a mail, so to speak, a letter. And if I want to if this letter is intended for C, okay, the switch acts like a post office. It will read this envelope, so to speak, and then I'll say, okay, I will send the mail to this address. Okay, I will send the piece of data to this address, and I will tell, and of course the mail will have the address of A and the address of B. Okay, so this is how Ethernet so-called works. I mean, conceptually is kind of that simple. The whole idea of Ethernet is to make sure everyone has a standardized format of sending and receiving these mail packets. Okay, so where for real life we have mail, snail mail. Okay, for real life we have snail mail. For Ethernet systems we have Ethernet packets, or no, not Ethernet frames. Ethernet frames. Okay, so this is the entire envelope. This is the entire envelope plus the mail inside. Okay, so this is something called an Ethernet frame, and this Ethernet frame has a standardized format. Okay, it's called the IEEE 802.3 standard. Okay, so it's called the IEEE 802.3 standards. Of course, there are other formats as well, but you can see that there are a little bit of, I mean, this is more or less what I covered, right? You have data, which is the contents of the letter. Okay, you have data, which is the contents of the letter. You have a source address, which is where you're sending the address from, and you have your destination address, which is where you're sending your address to. So when you have a long string of ones and zeros, the first thing you will have is this thing called preamble, then the start of frame delimiter. That one I have not quite explained, but then you must have your destination address and source address first. It must be in a standardized format. You cannot switch them around, if not you'll be confused. So IEEE 802.3 Ethernet frame format is standardized throughout all computers which use these Ethernet cables, so that when you send a string of data of ones and zeros using your voltage signal, it is understood by all of the computers because they use this same protocol. Okay, the format is sometimes also referred to as protocol. So whenever you hear the word protocol, you will see it just means that the way you format your ones and zeros and the way you arrange your data, it is the same. If the protocol is the same, the way you arrange your data in the strings of ones and zeros is the same. So this is what protocol is about. So this is the destination and source address. And what is the address of this that you put there? It is something known as the MAC address. So this is the MAC address. So yeah. So that one I can probably come to it later. This is a length, and this is data, and then this is a cyclic redundancy check. Now, why do you need so-called preamble, right? Why do you need a preamble? Okay, and why do you need this start of frame delimiter? Why do you need this cyclic redundancy check? And what is this length about? Okay, so okay, So this, let's go through some of the extra stuff, because this stuff is something we already covered conceptually. Why we must have source and destination address. It's very easy to think of it as a letter. So let's talk about the other stuff. Okay, so let's talk about preamble. Okay, so so picture yourself in a post office and you are the postman, right? Let's say you are the postman. Okay, and you're sitting on a chair. You're sitting on your chair, and then you are the postman or post lady, whoever. You're sitting on a chair. This is a stick figure, and you are trying to sort out mail, right? So I'll just draw a piece of mail here, and then all right. So you have your nice table, nice cup of coffee, and then what do you do? All right, you need to sort out mail, and then let's say you have a few trays down here. One goes to computer A, one goes to computer B, etc., etc., right? So this is what happens in the switch. You, being the postman here, will physically look at the letters, and then you dump the letters in A and B. All well and good. Now, the good thing about being a postman, if you're working as a postman and you have sight, is that you can see physically when letters come. Okay, you can see physically when letters come. However, in the machine here, in this Ethernet frame format, or in the world of digital communication or electrical communication, the Ethernet switch cannot see anything. You don't see a physical piece of mail, and the only thing you can see, the postman can see, is ones and zeros. Okay, the only thing the postman can really see is ones and zeros. So there's no way for you to decipher when the mail is coming just by looking. So imagine we have a blind postman, right? We have a blind postman. Okay, so I'm going to try to bring the analogy kind of there. Let's say you have a blind postman. Okay, a blind postman. Okay, and the only way this guy can actually interface, well, is using sound. Okay, the only way this guy can really learn to receive and so-called check letters is with the use of sound. Okay, because sound is like a 1D kind of a thing. You only have like one dimension, which is like one loud sounds and not so loud sounds, just like you have ones and zeros. So loud sounds may be a 1, soft sounds maybe is a 0, I don't know. Okay, so the only thing this guy can communicate with is using sound. Okay, and okay, let's say this post office, yeah, this is a post office in the real world. And in the real world, there will be lots of other distracting noises, right? You have distracting noises. You have distracting noises that are outside in the post office, right? And this will be analogous to, electrical disturbances, right? Yeah. Electrical disturbance. Okay, so the distracting noises are a bit like electrical disturbances, but just follow with the analogy for the time being. So let's say you're a blind postman, you can only hear sounds and to decipher where the letters are coming from, and there are lots of distracting noises outside. Okay, it's a noisy day, there are cars going by, there are people talking, and you're just trying to do your job to sort out the mail so that we can figure out where the letters are supposed to go. Okay, so how do you tell this postman in a noisy post office when a letter is coming? Okay, the way you can do it is maybe with the use of a ringtone, right? Something like a ringtone, right? Ringtone. Okay, the ringtone will tell the postman, okay, a letter is here, start paying attention, right? So the letter is here, start paying attention, start reading the addresses. Well, suppose there is a braille or something. Suppose there is a braille on the letter, and this postman can read braille very well and very quickly, so that it can sort out the letters. So a ringtone has to come, and then the postman will say, okay, let me start reading the what do you call that? The letters with Braille. Okay, so Braille is those dots that help blind people to read. So this is what Braille is about. It's very good stuff. Yeah. Okay, so the only way, because to get the postman's attention, is with the use of a ringtone, because you cannot have every single distracting noise coming by, and then the postman is like, okay, do I read this letter? Do I read that letter? No, the way to tell the postman, who can only hear, is with the use of some ringtone, and this ringtone will tell the postman, okay, ding, a letter is here, something like that. So this ringtone is a way to alert the postman to start reading the letter and to start sending the letter in the right places, and not send junk signals to A and B, right? So this is what actually happens in the switch. This ringtone is actually called, this is what the preamble is here, is supposed to do. Preamble. Okay, the preamble is here. It indicates the start of a frame and allows the sender to establish bit synchronization. Okay, basically what it means is that all the other ones and zeros I don't want to read. I will only start reading the ones and zeros and sending the ones and zeros once I see this preamble, this so-called ringtone, which tells the switch, the blind postman at the switch post office, so to speak, hey, a letter is here. Let's start looking for the destination address and source address. Okay, so so that's why there is this preamble thing. Okay, the SFD is this start of frame delimiter. Okay, so after the ringtone, you will have some, I guess you will have some spacing. Okay, after the ringtone, you will sort of have some and then the switch can start reading. You will look for this start of frame delimiter to see where the address is going to be read. Now it's a bit abstract over here. I'm not really sure how to go from this postman analogy for the preamble into this start of frame delimiter. But I guess if the postman, okay, if all the letters are so-called sonic letters, they are only like sounds and all. So the preamble will be telling the postman, okay, okay, you need to start reading the letter. And then this start of frame delimiter, I mean, since the postman cannot really see well, or see at all for that matter, the start of frame delimiter is going to tell the postman, okay, where do I put the finger? Where do I put my finger to start reading the addresses of Braille? So the SFD tells the postman, start of frame delimiter tells postman, okay, SFD tells postman where to place finger to read Braille. Am I spelling Braille right? Okay, I just did a quick Google search. You're supposed to spell Braille with double L. Okay, so pardon me for that. Okay, let me delete it. I took Braille on letter. Okay, so the start of frame delimiter. Okay, I need to tell postman where to place finger to read Braille. Okay, so that's I guess the best thing I can come up with now as to what the start of frame delimiter is. Okay, so that's the way to tell the postman where to put the finger so that you can start to read the letter. Okay, so next part doesn't really deal well with the postman analogy. Okay, it doesn't really do well. Doesn't really do so well with the postman analogy. Why? Because this involves the postman starting to read the letters. Okay, so the postman will actually start to open the letters and read the letters, which is kind of a breach of privacy, but that's where the postman analogy breaks down. So you have a postman who is blind and reading the contents of your mail illegally. Well, in this case, it's legal. I'm not really sure how else to put it, and yeah. So the postman will read your letter. Okay, for whatever reason. Okay, so that's the way it goes with Ethernet. Okay, the postman will start reading your letter, and usually over here, that how long the letter is will be appended in this length section. This length will tell you how long the letter is. Okay, this length will actually tell you how long the letter is, so that it will, if all the postman can read is Braille, then this length will tell the postman when to stop reading. Okay. Okay, so this length will tell the postman when to stop reading the data. Okay, but I mean length doesn't need that much of an explanation. It just tells you how many ones and zeros, how many bytes the data has. That's all. Okay, this is length plus data. And then lastly, what is this CRC? Cyclic redundancy check. And you might have heard of this term before called checksum, and usually it's in the error. Yeah, usually you will hear in the context of checksums as an error. Okay. So yeah, so what is this checksum here for? Well, you know that when you communicate using electrical signals, some of the data may be corrupted halfway. All right, some of the data will be corrupted halfway. All right, so let's say you send a string of ones and zeros from A to B using this letter format. How do you know the letter hasn't been tampered with? Okay, so normally in a letter, okay, sometimes you have this thing called a seal on this letter. You use wax, hot wax, and you paste it on. Now if the letter was open, this seal will be broken, and then you'll know the letter has been opened. Okay, so that's one of the ways you know the letter has been tampered with. Okay, so you don't have wax and candle wax and a seal for Ethernet frames or Ethernet packets. They got frames. That's a proper name. You don't have letters for that. So how do you so-called deal with this? So let's say okay, I have this letter, this poem that I want to send over from computer A to B. Maybe it's a song, famous hymn Amazing Grace. So let's say let's say you just want to send the two words Amazing Grace, right? Amazing Grace. Okay, Amazing Grace. Okay, Amazing Grace, and this is your message. Okay, how do you make sure that this Amazing Grace hasn't been tampered with? How can you provide a check? Okay, so maybe one of the ways you can think of is to maybe you say A is representative of the number 1. This A is representative of number 1. This A is representative of number 1. C is 3. E is 5, so on and so forth. I cannot just memorize the alphabet and the numbers at the moment. Okay, so let's say you have all these letters, and each letter will correspond to a number. Okay, so this is what? Yeah, let's say each letter corresponds to a number, and the way that you want to say that this message has not been corrupted is maybe you add all these numbers together, so on and so forth, and you have this sum over here. Okay, and then you maybe add this number, I don't know, 234, right? 234. So this number will tell you the sum of all these so-called numbers together, and this provides a simple way to see if this message has been tampered with. Okay, so let's say if I remove this letter G, for example, and then instead of Amazing Grace you have Amazing Race. Okay, yeah. So for some reason this message has been corrupted. So what the computer will do, or what the postman ought to do when he reads your letters to check if it's corrupted, okay, and that's why the postman is reading your letters. He will read your letters, and you see this A, M, A, blah blah blah, and then you see this race. Then you will repeat the process of adding all these numbers up, and then you will see that this number is something that is not 234. Maybe it's 229. Maybe it's 229 or something. Okay, so if this checksum, this number doesn't match this number, we will then say that, hey, this message is corrupted. We will want to throw it away, or do something with it. I don't know. Yeah. So this is the basic concept of a checksum. Of course, this is not that simple that we use this algorithm and just add numbers together. We might use some other more complex algorithm, or checksum algorithm, and checksum algorithms which help you generate a set of numbers, so that the computer will read the data packet, okay, read the ones and zeros. It will use this checksum algorithm to generate a number, and if this number matches this number, then you say, okay, I am more or less confident that the data is intact. I can feel confident about sending it from the post office to computer B. So that is what checksum is about. So in summary, we have of course covered some very basics about Ethernet frames, what data they contain, and why is it important to send it from one computer to the next computer, so that I don't if we have the hub situation, A will send a message, and then B, C, and D will all receive the same message at the same time. Thus, the information highway is so-called clogged up. That's not a good thing. So the way to do it is to use this switch, so that and then it will contain all these addresses and everything which are bundled inside this thing called an Ethernet frame, which is the entire envelope plus the mail inside. Once you have this, it will be able to send signals between multiple computers through something known as a switch without clogging up your whole information highway. Now with this on, I mean, maybe you don't just employ one postman, you have 15,000 postmen, I don't know, working simultaneously in the switch to do their job. I don't know what's the technology behind it, but this is probably a very layman way of understanding it. Yeah. So that's all I have for this video. Thanks for watching. I will see you again. Bye bye.